Good morning, everybody, and today we will give the method and determinant of the coefficients for non-homogeneous equations of order n. And if our equation non-homogeneous and has a right side, and for example, this one is called g of t, for example, and non-zero. This one is non-zero, so we know that then this and the differential equation is called non-homogeneous equation. So if differential equation non-homogeneous, have to find the general solution of the our differential equation. Let's give an example and look at this example, this differential equation. And this one is a linear differential equation and the order 3 and also non-homogeneous differential equation. So I have to find the general solution of this differential equation, and first of all, and also this differential equation, linear differential equation, and constant coefficients. Coefficient is 1, and this one is minus 3, 3, minus 1, and the constant coefficient. So first of all, first step, and find the general solution of the homogeneous part, and this one is 0. Consider and this differential equation. So we know how to find the general solution of the homogeneous differential equation. Write the characteristic equation, corresponding characteristic equation of this differential equation. And this one is r cube and minus 3r square plus 3r minus 1 is 0, characteristic equation. So, and find the roots of this polynomial. It's okay, this equation. And this one is the equation and r to the 3, and so this equation has a 3 roots. So, and our aim find all roots. So have to find these roots and look at the constant term. Look at the divisor of the constant term plus n minus 1, and so if these and the values right here, and so this one is 0, and then this value is a root of our characteristic equation. For example, and take the r is 1 and substitute here, and so we obtain n 0. 0 is equal 0. So, and it means r is 1 is a root. So if we have the one root, and it is easy to find all roots of the characteristic equation, because write our polynomial and divide by this one r minus 1, because r is root and r minus 1 is a factor of this one. So, and using the division algorithm, and then find the other roots of our characteristic equation. It's okay. And so we obtain this one. So, and this one is a product of the r square minus 2r plus 1 and r minus 1. So, and this one gives the repeated root, and also r minus 1 square. So we obtain the repeated root. 1 is a repeated root. It's okay. So if our root is a repeated root, and so let's write the general solution of the homogeneous part, and it's this one, and we know that e to the r1t is a solution of the r differential equation. R1 is a 1 here, so e to the t is a solution of our differential equation. But this one is the first y sub 1, this one. And so c1 times y sub 1 and c2 times y sub 2, but repeated root, and should be fundamental solutions linearly independent. So, and if take the y sub 2 e to the t, it is not true, because this one is this one the same and the same. So not linearly independent. So, and the y sub 2 should be t times e to the t, and next solution, fundamental solution should be t squared e to the 2, because it should be linearly independent. So we obtain the general solution of the homogeneous part. It's okay, homogeneous differential equation. And here, but our and differential equation non-homogeneous. So the next step, step 2, and find and the particular solution of the our differential equation. So, and how to find and this one, let's use the undetermined coefficients and the method. It's okay. So, and look at the right side of the differential equation. Right side is this one. It's okay, g of t. And how to find the particular solution? Look at this and the differential equation and construct the form of the particular solution. So this one is e to the t, 4 times e to the t. So particular solution should be this form, a times e to the t. But be careful, if take this one is doesn't work, and if and compute the y prime and y double prime and so on, substitute our differential equation, we get contradiction, because this one is, it is not true. It's okay, correct form. So what's the reason? Because look at this one, e to the 2, c1 times e to the 2 is a solution, and this one is a times a is a constant, c1 is a constant, e to the 2. So the same, and this and the part contains these solutions. But our aim to get the fundamental solutions linearly independent. So, and this form, it is not true. It's okay. So, and our aim is to construct the form of the particular solution. First of all, you have to check and look at the general solutions. It's okay, solutions, fundamental solutions. And exist, and here this form, and it doesn't work, our form. So, and this one is, it is not true, so multiply by t, but and this form exists here, and so this one, it is not true, and so multiply t square e to the t, and also this one is the other and the solutions, so it doesn't work, so multiply t cube. It's okay, form is this one. Yes. And so, and this one, it's okay, our form should be this one, and for particular solution. So our aim is to find the particular solution, means, and the next step, find the value of a. It's okay, value of a. How to find value of a? We claim that y sub p is the correct form, should be particular solution, and particular solution means solution of our differential equation. So this one is a solution of our differential equation, means satisfy our differential equation, write the y sub p, y sub p, y sub p, and so on, and this one should be for e to the t, and so you have to compute prime and double parent and so on. So, and take this one, differentiate with respect to t, use the product rule here. We know that if u is an sorry, and the product rule, u times v prime is equal first derivative of the first one times the second one plus first one times derivative of the second one. Use this formula to compute the derivative. It's okay. So, and this one is u, this one is v. It's okay. So y sub p prime is equal u prime. U prime gives 3 times at squared times second one e to the t, and first one times derivative of the second one e to the t. It's okay. So, and rewrite this one, it will be better to compute and the next derivative. It's okay. So, and look at this one, e to the common and the factor, and the right and this one. It's okay. And then take the derivative of the and this one, and differentiate with respect to t, and again, and use the product rule. This one is u, this one is v. U prime times v, u times v prime. It's okay. And so e to the t common factor and write, and this one rewrite and differentiate with respect to again, and then we obtain all derivatives here about our differential equation. It's okay. So we know that our y sub p satisfied our differential equation. It's okay. So right here and take this one and substitute our differential equation. So compare the two sides. It's okay. Two sides. Left side should be right side. It's okay. So we obtain here, and the 6a e to the t should be 4 e to the t. Compare the both sides and the coefficient of e to the t and the cancel e to the t. We know that and the e to the t exponential function not zero, and it is possible and cancel. And so compare the both sides, and 4 times a should be 4. It's okay. So a is 2 over 3. And write here y sub p a times t cube e to the t. So we obtain particular solution. It's okay. So what's the general solution? General solution, and right here, general solution. General solution, y sub h plus y sub p 2 over 3 t cube e to the t. This one is the general solution of the differential equation. Yes. Any question? Any question? No question. Okay. Next, consider another non-homogeneous equation. This one is and first identify this equation. A linear differential equation. Order is 4 and with constant coefficients, and also non-homogeneous differential equation. First of all, write the characteristic equation. So characteristic equation, this one gives complex numbers. It's okay. And also repeated complex numbers. So, and they take this part. So we know that, and the lambda is 0, nu is 1. It's okay. E to the lambda, e to the 0 is 1. So C1 times cosine nu t plus C2 times sine nu t. Nu is 1, and so sine t. So, and this one gives the first, and this and the corresponding, and this one is the first one, and the fundamental the second one, and also this one is the repeated root, and also and means, and it should be a fundamental solution, and the other ones. And so cosine t multiply by, and take this one multiply by t, and we obtain the others. It's okay, this one. So this one is the general solution of homogeneous differential equation, the corresponding homogeneous differential equation. So next one, to construct the y sub p and look at the right side of the differential equation, this one contains sine and cosine. So particular solution should be, and a times cosine t, b times sine t. Sorry. But look at the general solution of homogeneous part, and this form is not correct, correct. This one doesn't work, because what's the reason? And the general solution of homogeneous parts contains, and this one not linearly independent, this one. So and multiply by t, but multiply by t, we obtain this form, and the general solution contains this form. So this one is not true. It's this form is not correct. So multiply by and t square is okay, t square. So this one is our form of the particular solution. It's okay. So this one is particular solution, and next step, our aim is to find the coefficients a and b, value of a and A and B. It's okay. So, and this one is particular solution, and means the solution of our differential equation satisfy our differential equation. This one and this one should be right side. So, and compute the derivative of the y sub p, and here again using the product rule, and the u times v, and another v is here, and the first one derivative of the first one 2 times at, and the second one, and the first one derivative of the second one, and this one is okay. So, and we obtain, and the derivative of this one gives these terms. It's okay. So we obtain y sub p prime. So, and the rewrite, it will be better to compute the y double prime and the cosine t and the common factor, and we obtain this one and this one, and then differentiate with respect to t again, and using the product rule, and then we obtain under this one. And also this one is the order, our differential equation order 4, and so again we have to differentiate with respect to t, and then differentiate with respect to t, and we obtain all and the derivatives in our about our differential equation, and substitute here, and this one should be right side. So, and the sum computation, and we obtain, and on the left side, and the cosine t and sine t should be this one. So compare the coefficient of cosine should be -5, and this one -8a minus 5, and we obtain the value of a, and the coefficient of sine t should be 3. It's okay. So we obtain value of b, and particular solution, our particular solution this one. It's okay. A times, and this one b times t square sine t. Yes. Any question? Okay, no question. I hope everything is clear. And so the next question, non-homogeneous, but and also right side sum of the, and the sum functions is okay, and the polynomial, trigonometric, and exponential function is okay. So if r and the differential equation, right side of the differential equation g of t, the sum of several terms, and this one, and this one, so sometimes, and we obtain, and the sum differential equation, this one is the first one, and take this one, the second one, this one is the third one. It's okay. And they consider these differential equation and find the solution. It's okay. But, and first of all, and our aim is to find the particular solution of the given equation, but always you have to find the general solution of the homogeneous part, because and the particular solution and the form, and construct the particular solution forms, consider the right side, and also the general solution is important, and the general solution of homogeneous part important, because and the particular solution should be fundamental, linearly independent. It's okay. So, and first of all, you consider the homogeneous differential equation. This one is 0, and write the characteristic equation, because and the linear differential equation constant coefficients, write the characteristic equation. So, and this one is gives, and 0, and also plus and 2, plus and minus 2 roots, and also our differential equation order 3, so we obtain 3 roots. Is okay. So this one gives the, and this, and the solution, and this one gives, and the second one, and the third 1. It's okay. So the general solution of the homogeneous part and this one. Yes. Now let's construct the particular solution, our particular solution. It's okay. But look at the right side, the sum of and the sum and the sum of the several terms, and so particular solution of differential equation is the sum of particular solution of these differential equation, this one, and this one, separate parts. It's okay. And the first one gives sorry, and this one, and so sorry, this one, and the second term gives the second differential equation, this one, the corresponding differential equation, the last one. It's okay. So and let's consider the first differential equation. It's okay. This one is the right side is a polynomial. It's okay, polynomial. So and the particular solution y sub p is the particular solution of the first differential equation is denoted by y sub p1. It's okay, p1, and should be polynomial, and so should be this form a2 at plus b. But and this one doesn't work because and take the differentiate with respect to again and again right here, and we obtain for example, let's see that we obtain contradiction. If form and this one is polynomial degree 1, so R, we claim that our particular solution form should be this one, a polynomial of degree 1. So and this one is our particular solution. So and the compute the derivative by sub p1 is okay, p1 a, and so double prime is okay, should be 0, and the next derivative should be 0. So it's okay. So and they substitute our differential equation. Our differential equation is this one, and right here, sorry, it's okay, and 0 minus 4 times y sub prime. Y sub prime, this one, a should be t. And we obtain minus 4a is t, and the coefficient of t is 1, but coefficient of t is 0. 0 is equal 1. We not possible, and so we get contradiction. So means this form it is not true. It's okay. So what is the reason this form doesn't work? Because look at the general solution of the homogeneous part. It's okay, homogeneous part. Look at the general solution. Yes, here general solution. And this one contains is a constant term. It's okay. So here constant term is okay. So and the constant is a solution of the our homogeneous equation. So and this one is doesn't work, multiply by t. So we obtain this one, this form. So we claim that this one is the form of the particular solution. And so yes, the first one. Look at the second one. Second differential equation. So particular solution should be this form. So form our particular solution. The second differential equation, and it should be this form. It's okay. Contains trigonometric function cosine or sine, and so our form should be and c cosine t d sine t. And look at the next one, next term. This one exponential. So form of the particular solution, the last equation, and it should be at e to the minus 2t, because on the right side is e to the minus 2t, but this one is the solution of our differential equation, homogeneous part. So multiply by t. It's okay. T. Any question about the form of our differential equations? Any question? Okay. No question? Okay. So now the next step, find the coefficients and the unknowns. It's okay here. The value of coefficients A and B. A and B, and you have to find C and D and E. It's okay. So how to find? We know that, and this particular solution of the corresponding uh, differential equation. Compute all derivatives. Okay. So and compute here, and this one, and this one, and substitute our differential equation. It's okay. And so here, and sometimes, and separate the differential equation and y sub p of the r, the main differential equation, the sum of the particular solution, and form this one, and compute the prime and double prime and so on. Or and the separate parts and find the first one, and then find the second particular coefficient of the second particular solution. It's okay. So and consider the corresponding first differential equation. This one is okay. Substitute and here it's okay. This one. And take this one and substitute our differential equation. It's okay. So we obtain under this one, and so compare the both sides. Coefficient of t and this one should be 1, and the constant term and the for and the b is should be 0. It's okay, and we obtain b is 0. A is minus 1 over 8. So and the particular solution a t square plus bt. B is 0, and so we obtain this one. It's okay. So and the next second, the correspond second part, and it gives the second term, gives the second differential equation, the corresponding differential equation, and so and take this one and substitute this here, and using this substitution, and we obtain this one should be right side 3 cosine t. It's okay. So compare the coefficient of cosine and sine. So we obtain 5c is 0, c is 0, and the d is this one. So and the coefficient of cosine and the c is 0, so 0 plus d times sine t, and so we obtain this one. Yes. And the last differential equation, this one, and the particular solution should be this form, and take the all derivatives, substitute using the substitution, so we obtain this equality. So compare the coefficients, and this one should be 1 here. So and we obtain value of a is this one. It's okay. So we obtain particular solution. Particular solution of the main and the main differential equation. Particular solution of y sub 1 is okay. Particular solution of the y sub 2 and y sub p 3 is okay. This one is the particular solution of the main differential equation. Any question? Okay, no question. And we know, and from the last lecture, this one is homeworks. It's okay. About the differential, homogeneous differential equation. It's okay. And the axis and rules, and they choose to some of them. This one gives, and it is easy to get, and let's skip and this one now, and let's give the method of the variation of parameters and for the non-homogeneous differential equation. It's okay. The other method to find the particular solution of the our differential equation, non-homogeneous equation. It's okay. So and this and the method is the same method, and as for second order differential equation, it's okay. So and for example, and let y sub h and this one is okay, the general solution of the homogeneous differential equation. If our differential equation order n, so and the general solution of the homogeneous differential equation contains n fundamental solutions. Fundamental solutions should be, and it means Wronskian determinant should be non-zero. It's okay. Y sub 1, y sub 2, y sub n. Fundamental should be Wronskian non-zero. So our aim and to construct the particular solution of the form and then find the particular solution. And look at this one, the general solution of homogeneous and differential equation. Particular solution form as this one should be, and means and the C1 should be U1. We know that, and the C1, C2s, and Cn constant here. It's okay, but here U1 is a function of t. It's okay if variable t, and the U1 is U1 of t. It's okay. U2 is ut of t, and the variable t here. It's okay, and so on. So, and the form of the particular solution should be this one: u1 y sub b, u2 y sub 2, and un y sub n. It's okay. And our aim here and find u1, u2, and un. It's okay. And how to find this and the functions is okay, u1, u2, un, and but we claim that this one is a particular solution under this and the condition u1 and u1 prime y sub 1, u2 prime, not u2, u2 prime. It's okay. This one is un prime y sub n should be 0. It's okay. But and be careful, we know and this and the method and for the second order differential equation is okay, and our differential equation should be in standard form. Standard form is the coefficient of y square is should be y double prime. Sorry, should be 1, and also and the standard form is this one if and these are differential equation order n. It's okay, and this one. So, and in the standard form, and means, and this one is 0, homogeneous, should be, this one is should be 1. It's okay. And also non-homogeneous, and our differential equation, and they should be, and the g of t is in the standard form. If this one is the standard form, and the right side is g of t. Otherwise, not standard form, and the first of all, and the R and the differential equation can be transformed into the standard form. It's okay, and then solve the R differential equation. It's okay. So, and our aim here find the u1, u2, un under this and the condition u1 prime y sub 1, u2 prime y sub 2, and un prime y sub n prime should be 0. And we have, our aim is to find the u1, u2, un, and the number of unknown n. So we know in the linear algebra, our aim is to find the all unknowns, and you have to get and the n equation, n unknown and n equation. If the coefficient matrix determinant of the coefficient matrix non-zero, so we obtain unique solution. It's okay. We know this one from linear algebra. So, and this one is the first equation, and the second equation, take this one, the coefficients the same, but take the y sub 1, y sub 1 prime, y sub 2, y sub 2 prime, y sub n prime should be this one. And the next row should be u1 prime, y sub 1 double prime. It's okay. And plus u2 prime, y sub 2 double prime, and so on. Un y sub n double prime should be 0, and the previous one is gone. And the next one, the last one, and this should be this one, is if and r and the differential equation not standard form, and this one y sub and this one plus is equal g of t if this one. So, and what is the g of t here, and in the standard form, and divide by 1 over an, so we obtain right side g of t over an. It's okay. And if an is 1, g of, and this one gives g of t, of course. It's okay. And so we obtain and the linear system here we obtain. It's okay. This system contains unknown and unknowns. It's okay, and unknowns. And the u1, u2, un prime, and the first unknown, and second unknown, and the last unknown. It's okay. And our aim is to find all unknowns. We have an equation, first equation, the second one, and the last equation. So this one gives the system, and our aim is to solve this system, and the coefficient matrix should be non-zero to get the unique solution. It's okay. Determinant of the coefficient is also, and we know that, called the Wronskian determinant. We know that Wronskian determinant should be non-zero, and also this one is the coefficient matrix. So we obtain the solution, and find the u1 prime, u2, un prime, and integrating both sides, and so we obtain u1, u2, un. It's okay. Yes, let's give an example to understand this method in for the general and the linear differential equation, constant coefficients. Look at this one, and the order 3 and the linear differential equation, non-homogeneous because right side not 0, and the constant coefficients. So our aim is to find the general solution of this differential equation. And we know under this one, so, and write the characteristic equation this one, we obtain the solution. R minus 1 is a solution, so we obtain this one. And this one gives the multiple roots. R is 1, is root. So e to the t multiplied by t, we obtain the next fundamental solution. So this one is a general solution. It's okay. But here, and look at the right side exponential function, and here we can use the undetermined coefficients. It's okay method because it's the exponential. So particular solution in this form. What's the form? A times e to the t. It's okay. If, and here our aim is to get the particular solution by using the undetermined coefficients. But look at this one, e to the t here, so not linearly independent, so multiply by t, but here, and also second fundamental solution. So this one doesn't work, so particular solution should be a times t squared e to the t, should be this one. It's okay, this one. And so find the coefficient a, it's okay. And so compute the derivative right here, find a. This one is homework. Find the particular solution by using the method of undetermined coefficients. But here, not use this method, let's use the method of variation of parameters. It's okay. Of course, use the undetermined coefficients of variation of parameters. We can obtain the same particular solution. It's okay. So, and this part homework is okay. and find the particular solution by using the method of undetermined coefficients. Now, let's use this method, new method. It's okay, variation of parameters. So look at the general solution of homogeneous and general solution of homogeneous equation. So construct the particular solution. And the C1, U1, C2, U2, and C3, U3. It's okay? Particular solution this should be formed. But if use the undetermined coefficients, particular solution form of the particular solution this one should be. But look at this one, it's a different, it's okay? This one. But we claim that and the particular solution the same, should be same. It's okay? So anyway, and then and let's find the U1, U2, U3. It's okay. Yes, yes, what is the we got the our aim is to get the U1, U2, U3 and particular solution this one under this hypothesis, and this one is U1 prime e to the t, U2 prime, U3 prime should be 0. Yes, the next one. And take the derivative, and U1 prime, take the derivative of e to the t, e to the t. Take the derivative of this one and use the product rule, and derivative of t 1 times the second one e to the t plus first one times derivative of the second one e to the t. So we obtain this one. So derivative of this one minus e to the minus t. It's okay. This one should be 0. And the next one, yes, take this one, take the derivative of this one, e to the t. Derivative of this one gives this one. Derivative of this one gives this one. Should be g of t, but if our differential equation standard form, look at this one, is the coefficient is 1, yes, in the standard form. So g of t this one for e to the t, yes. So and we have and the 4 unknown, it's okay, we obtain and the 4 equation. This one is the linear system. So and let's find the coefficient matrix, and also and this one is the Wronskian, and the coefficient of first unknown is okay. We obtain first column. Coefficient of second unknown, we obtain second column, and the coefficient of and the third one gives the last columns. Sorry. So and look at this determinant. We know how to compute this determinant by using the properties, and the first column and the gives e to the t because common and the factor, and the second column contains e to the t, and second column gives e to the t, and the last column gives e to the minus t. So first column will be 1 1 1, and this one, and the last one minus 1. And so it is easy to compute now. It is easy to compute this determinant using the elementary row operation, and it is easy to get 1 0 0 column here using this elementary row operation. So using the column expansion, last column expansion here, because and the last column contains only one non-zero entry, so we obtain this one. So and this one, this determinant gives 4 times e to the t, and we know that and this one is always non-zero. So and by using the and our solutions particular fundamental, so and have to find the unknowns u1 prime, u2 prime, u3 prime, and using the here Cramer's rule. And so u1 prime, first unknown u1 prime, and Wronskian determinant, yes, and this one and the first row will be right hand side. Our aim is to find the first unknown, so first column should be right hand side, 0, 0, 4. And the second one and the last column stays the same. Look at this one. So, and we obtain this one. U1 prime is equal this one. So, how to obtain and the U1? Integrating both sides. So, we obtain U1 is minus T square minus T. Yes. Now, let's find the second unknown, U2 prime. 1 over Wronskian, and the second column, look at the coefficient matrix and this one. And our aim is to find the second unknown. So, second column will be right side. It's okay, right side. So, and second column will be right side. Yes, this one. And using some properties, because look at this one, first column contains and the common factor e to the t, and the first column gives e to the t, last column gives e to the minus t, so we obtain this one and this one. So it is easy to compute this determinant using the second column expansion. So we obtain only 1 and the 2 by 2 determinant, and this one gives and this one, and so multiply this one, we obtain 1, and this one gives minus 2, non-zero. It's okay. Yes, u2 prime minus 2, integrating both sides, we obtain minus 2t u2. And the last unknown, u2 prime, 1 over Wronskian, and the last column will be right-hand side. So, and it's using the some properties of the determinant. So we obtain the result. U3 prime is this one. Integrating both sides, we obtain U3. Yes. So write the particular solution. U1, we know that the particular solution this one, and the substitute value of U1, U2, U3 is okay. And this function, U1 is this one, U2 is this one, U3 is this one. Okay, so we obtain particular solution this one. And we obtain this one contains t squared, t and constants e to the t. But let's come back our question at the beginning. It's okay. Look at this one in the homework. Let's consider homework. It's okay. We claim that if use the undetermined, use a different color, maybe it will be better. Look at the right side. Particular solution should be this one. A times t square e to the t, and this one homework, and find the coefficient a. It's okay. So, and we obtain this one. But here, particular solution. Look at our particular solution by using the variation of parameters. This one. T square e to the t, but and contains t e to the t and constant. And but particular solution should be is this form, a t square e to the and the t. But and so not the same. It's okay. What is the reason? Because we obtain the same general solution. What's the reason? Take this one particular solution. This one gives and this one particular solution. We know and the general solution of our non-homogeneous differential equation is equal the sum of general solution of homogeneous part and plus particular solution. Right here, the homogeneous part is this one plus particular solution. Look at this one. It's okay. So and look at this sum. E to the t, this one, e to the t. So we obtain C1 times 1 over 2 e to the t. It's okay. And next one, t times e to the t, this one. And also here, t times e to the t. So, and we obtain this one, C2 minus 1 TE to the T, this one. And also, using the different color, and this one, and so, and the last one, T square E to the T, is this one. So, look at this one, and this one is T E to the T, and this one is, for example, C2 prime, and not prime, and the capital C2. It's okay. This one is capital C2. This one is capital C1. It's okay. So we obtain C2 TE to the T plus C1 E to the T plus and plus C3 E to the minus T plus this one is capital C1, capital C2, T square E to the T, y sub P is this one. It's okay? So we claim that and the particular solution by using the undetermined coefficients, so and the particular solution this one should be A is 1. It's okay, homework, and this one is a homework and the part. It's okay. So, and we claim that A is 1, so we obtain this one. It's okay? So, particular solution by using the undetermined coefficients, particular solution by using the variation of parameters, but we obtain the same and the general solution. It's okay? Because what is the reason? And the right here, and the reason here. It's okay? So, we obtain same. Any question? Okay. No question? Okay, this one is homework parts. It's okay. Now let's here and some homework and this one is from your and the textbook and the page number this one 244 and the question 1 and this one second problem and the page number and question number this one from your book. It's okay, textbook. And so and the second one solution this one. It's okay, this one. And but here be careful, look at the right side, non-homogeneous second T. So and it is not possible to use the method of undetermined coefficients. So you have to use and for this question you have to use the variation of parameters and also this one variation of parameters. It's okay to get the particular solution. Yes. Yes, let's stop here. Any question? But and consider this one. It's okay. In the tangent T, last question, and the homework, and also, and look at the corresponding homogeneous and the differential equation. Find the roots, and we obtain, and the order is 3, and so we obtain, and the characteristic equation, and the polynomial is degree 3, so we obtain 3 and the roots, and the first one 0 and the second one gives complex numbers. It's okay. So and the e to the 0 and here e to the 0 is 1, so we obtain c1. And this one is, and we know that lambda is 0 and the nu is 1, e to the lambda t times c1 cosine and the nu t plus c2 sine nu t. And right here lambda is 0, e to the 0 is 1, and we obtain this one is c2 c3. It's okay, we obtain this part. So particular solution, you have to use the variation of parameters because right hand side not polynomial function, not sine plus cosine, not exponential function. You have to use the variation of parameters, and so should be C1 U1, C2 U2, C3 U3. Write the equation, and so we obtain and design this system, and compute the Wronskian determinant. Wronskian determinant 1, non-zero. So use the Cramer's rule. It's okay. So we obtain U1 prime, first unknown. U1 prime is, yes, 2 times tangent t, integrating both sides, and they rewrite, I think it will be better to see that the result, and tangent t, sine t, cosine t, using the substitution, and u is cosine t, so this one is u prime du over u, is okay, this one. So this one is ln u. Ln u, u is back substitution cosine t, so we obtain this one. It's okay, minus 2 ln cosine t u1. And u2 prime, and this one is okay, and u2 prime is equal minus 2 sine t, integrating both sides, we obtain u2 is 2 cosine t. u3, and we obtain u3 is this one, it's okay, and how to integrating this one, and using some properties. Sine squared t is equal 1 minus cosine squared t, because sine squared plus cosine squared is 1, and right here, so, and this one if obtained, and this one gives 1 over, take this one, 1 over cosine t, and this one gives cosine t plus cosine t, integral and cosine t, and gives the sine t, it's okay, and minus sine t, and also minus, and 1 over cosine t, and the ln secant t plus tangent t. So we obtain particular solution, u1 times y sub 1, y sub 1 is 1, u1 this one, u2 times cosine t, ut is 2 cosine t times cosine t, we obtain cosine square t, and this one is u3 and times y sub 3, it's okay, sine t, this one. So we obtain particular solution. Any question about the solution? Any question? No question, okay. Let's stop here, it's okay.